Students, I am going to discuss about part programming for a CNC lathe. This component is to be produced on a CNC lathe, for which we have to write the part program. The raw material is a round rod of diameter 60, length 150 mm. The raw material is shown in hidden line. The finished contour of the workpiece is shown in solid line. Before we start writing the part program, we have to know the axis in a CNC lathe. So this is the block diagram of a CNC lathe. This is the chuck of the CNC lathe. The tool turret can hold more than one tool, and the slant belt. Okay, the CNC lathe is normally having a slant belt. The x-axis is the movement of the tool turret over the slant belt in this direction, and the z-axis is the movement of the tool turret in the axial direction. So these are the two axes we are going to consider for writing the part program for machining this component. So this component involves two operations: facing the end of the bar and turning the contour. Let us see how to do these two operations using a single tool. So there are two axes in a we can consider in a CNC lathe. We can write the program based upon workpiece coordinate system, WCS origin. So we can consider this as the origin for WCS, workpiece coordinate system. The machine coordinate system will be having the origin somewhere here. It is easy to write the part program based upon the workpiece coordinate system. So when you take this as the origin, so towards the right side, that is the positive z direction, towards this direction is the positive x direction. So normally it is better to consider the right end face axis as the origin for workpiece coordinate system. So when you take this as 0, 0, what will be the coordinate of this point? So on x-axis it is 40, on z-axis 0. This point 40 minus 60. So x is 40 and z-axis is minus 60, because this is 0 as far as the z-axis is concerned. So moving towards left side is the negative z, minus 60. And this is the point whose coordinate are x is 50, z is minus 100. This is 50 minus 120. This is 60 minus 120. Let us first see how to do the facing operation. For doing the facing operation, we are going to bring the tool from its machine home position to this point rapidly. Then after rapidly moving the tool to this point, we are going to move the tool towards the center. Then we are going to take the tool again back to this point. Then we are going to take the tool to the home position. So let me show the movement of the tool for the facing operation. Now the tool is at its machine home position. From this point, the tool is taken to this position for doing the facing operation at a rapid traverse. From this point, the tool is moved towards the center at a specific feed rate. Then after that, the tool is made to dwell for a certain period of time. Again, the tool is taken back at a specific speed rate. From this point, it is taken back to the home position. So that is what is shown in this sketch. For the facing operation, okay, from this machine home position, okay, using G00, it is taken to this point. Then using G01, it is taken towards the center. Then, okay, using G04, the tool is made to dwell for a certain period of time. Then again, the tool is taken back to initial position, okay, using a specific feed rate. Then it is taken to the home position. In this way, the facing is done 2 times on the end of the workpiece. When the tool is moved towards the center, the facing is done. Again, when the tool is moved towards the initial position, again the facing is done. There is nothing wrong in making the facing in 2 times. Otherwise, the alternative is to make the tool to come here, then the tool is made to move towards the center at a specific feed rate, then the tool is made to dwell for a certain period of time, then the tool can be taken towards this direction. Okay, so in this way, the facing can be done with only one pass. We are going to write the program based upon this movement of the tool. So from the home position, it is taken to this point rapidly, then it is taken towards the center, then it is made to dwell, and it is again taken back at a specific feed rate. From here, the tool is taken to the home position. So now let us start writing the part program. So this symbol is used to start the program number. Then N1 is having the safety block. G18 is the selection of the XZ plane. Now the tool has to be moved on XZ plane on a lathe. So G18 is indicating the tool movement is on XZ plane. G21 to invoke metric coordinate system. G40 to cancel tool nose compensation. G49 to cancel tool length compensation. G80 to cancel canter cycle. Second line, we are going to fix the maximum spindle speed using G50 command. The maximum spindle speed is set to 2000 rpm for this example. Next line, the tool for doing the machining operation is selected from the T05 register, and the tool length compensation is to be considered from the register D05. Next statement, G96 is used to fix the constant surface speed to 200 meter per minute. When you want to use constant surface speed, we have to use G96, and M03 is used to switch on the spindle in clockwise direction. G54 is the command to be used for relating the workpiece origin and the machine origin. Next line, M08 will make the coolant to be switched on. Now comes the first movement. From the machine home position, the tool has to be brought to this point. Okay, this point. So that is what is shown here. Okay, G00 rapid traverse to a point whose coordinate is x60, z0. Then for doing the facing operation, we are using G01. G99 is used to express the feed rate in mm per revolution, and the end point of movement is x0, z0. Then upon reaching the center of the workpiece at its end, we are making the tool to dwell for a period of 2000 milliseconds. So G04 is used to okay, indicate the dwelling of the tool, okay, with a P 2000 millisecond. Then the tool is again taken back to initial position G01, X60, Z0. Then once the phasing is over, the tool is taken back to its home position using these two lines. So G28U0, G28W0 will take the tool back to its machine home position. Then next one is we have to start the turning operation. So for starting this turning operation, we are bringing the tool from the home position, okay, to a point just 5 mm ahead of the corner of the workpiece. So now this is the machine home position. Using G00, we are bringing, okay, just 5 mm ahead of the starting of the turning operation. Okay, once the tool is reaching here, then we can use G01 to move the tool slowly to this point. Then from here, okay, using G01, we have to use G01 for moving to this point. Then from here, we have to move to this point. From here, it is moved to this point. After that, it has to be taken back to the home position. So G00, X40, Z5 will take the tool to this point. So this point has a coordinates of, okay, X40 and Z5. So from the machine home position, the tool is rapidly traversing to this point whose coordinates are X equal to 40 and Z equal to 5. Next action, okay, we start doing the turning operation using G01. The next point is X40, Z minus 60. So if you look at this diagram, okay, from here it is slowly moving, okay, to this point. So okay, this point is having a coordinate of 40 minus 60. So 40 minus 60, the feed rate is 0.4. Next point, having a coordinate of 50 minus 100. Okay, 50 minus 100, then 50 minus 120, then 60 minus 120. So all those things are written one by one. Okay, so 60 and Z coordinate is same as previous one, so that is not repeated again. So this command, okay, is the end of the turning operation. So the tool has been used to turn in a single pass. So okay, after phasing operation is over, the tool is moving from here to here, then from here to here, then from here to here, then from here to here. After that, it has to be taken to the machine home position. So now the G28U0, G28W0 will take the tool to its machine home position. Then we are switching off the spindle using M05. Then we are switching on the coolant using M09. Then we are stopping the program. Program is stopped using M30. Then this is the end of the line. Students, we have written this part program based on two assumptions. First one, for doing the phasing as well as turning operation, we are using the same tool. The second assumption, the tool and the machine is capable of turning the required size in a single pass. The tool is made to move on this contour, that we are able to get the feature component in one single pass. So these are the two assumptions we have considered for writing a part program. And sometimes there is no need to do the phasing operation. So when there is no need to do the phasing operation, that phasing, the line used for phasing operation can be removed from this program.